Una po, thank you so much to Dr. Dindy for actually giving us a fairly um, broad overview of alkenes. So from yung real-life application of alkenes, nomenclature, structures, synthesis of alkenes, how these chemical species are actually produced industrially, application. So gaya na nga po na sinabi ni Dr. Dindy, you will see alkenes present in a bunch of things that we use on a daily basis. And then she also went over the different classes of reactions that alkenes undergo. And so kung napansin po ninyo, napakarami. There's actually a plethora of organic transformations that alkenes undergo because, like the presence of the double bond, of the carbon-carbon double bond there is making these molecules reactive. So ang dami po nilang pwedeng i-undergo na chemical transformations and ang daming iba't ibang klaseng products na pwedeng ma-form. And so this time around po, so if you could just like imagine, ang dami po ng reactions po. My intention for today is to actually not cover all of the mechanisms po nun kasi buong textbook yun, aabutin po tayo siguro ng mga ilang buwan bago po natin ma-cover yan. But then, my main objective for today is, as the title of my part of this seminar suggests, is that I will introduce you to organic reaction mechanism. So essentially po, ang ginagawa naman natin palagi is we're trying to deliver the concepts in the simplest way possible na ma-appreciate po ng ating mga estudyante at guro sa high school level, and then again at the same time this could serve as a refresher course to college students or college educators who might need to actually brush up on their organic reaction mechanism skills. So yun po. Okay, so moving forward, so what should you expect from this discussion? So okay, there are several parts to this talk of mine. So I'll start with the definition of organic reaction mechanisms, and then after that, gaya ng ginawa ni Professor Dindy, I'll also talk about some prerequisites. So ano ba yung mga kailangan yung malaman para magkaroon kayo ng medyo malalim na appreciation of organic reaction mechanism. So essentially, paano ba yung hindi nyo siya kailangang i-memorize? Yung isang tingin nyo pa lang sa molecule, alam nyo na kung anong parts ng molecules yung mag-react, which atoms will actually form a bond, which connectivities are to be broken when these chemical species undergo a chemical reaction. Fundamentally speaking, yung third item po na aking i-discuss for today will be the formation and breaking of chemical bonds. So yun po yung isa sa mga pinakamahalagang aspects of organic reaction mechanism, and I will show you why that is very important. The fourth part is the art of arrow pushing in reaction mechanism. Lalong-lalo na po sa organic chemistry. We typically represent the steps involved in a chemical reaction by using arrows. So yun po, ituturo ko yan sa inyo, the basics. And then, we'll be showing you some examples po. So for this particular lecture, I'm actually focusing on polar additions across a carbon-carbon double bond. So yung unang type ng chemical reaction that Dr. Dindy mentioned earlier. So for example, if you're adding an acid across an alkene, ang tawag din po dyan industrially, bukod sa alkene, those are called like olefins. So yun po yung mga example na gagamitin ko sa inyo. I will try to demonstrate things using yung ating slides, but then again at the same time, while Dindy was going over her talk, I also prepared models po para sa inyo, para ma-demonstrate natin kung paano ba talaga yung transformation. So magpapaka-vlogger ako, ganyan ako mamaya. So anyways, all right, so let's start with a definition of reaction mechanism. So how is reaction mechanism defined? So a reaction mechanism is a formalized description of how a reaction takes place. So essentially, it talks about how we get from reactants to products. So ano ba yung pinagdadaanan? Ano ba yung mga steps that chemical species undergo during a reaction for them to form the final product? And when it comes to organic chemistry, the focus is actually on the connectivity of the atom. So with that, ang ibig sabihin po natin dyan ay structures. So we're dealing with structures. And then secondly, and I think like when it comes to organic chemistry, we actually draw a mechanism and represent the movement of electrons using arrow. So movement of electrons. Bakit ba tayo mag-focus sa electrons? Ano ba ang fundamental component of matter that's involved in bonding? So di ba po electron? So yan ang ating focus ngayon, more particularly valence electron. So dun sa mga estudyante natin, ngayon alam niyo na kung ano yung unang nating prerequisite. It's actually an understanding of electrons and how they are actually used to form bonds, and and how those are they are actually crucial in the connectivity of the atoms in a particular structure. Okay, so sabi ko nga, all of our examples are actually going to be, all of the discussions for today will be predicated around this type of reactions. It's a polar reaction of an alkene. So essentially, you are adding hydrobromic acid to ethylene, or to ethene, to form a product that is called bromoethane. So JP, can you guys see my cursor? And I'm using the pointer.
Yep.
Okay. Opo. So ito, what's happening is this is ethene. This is a C2 alkene. So essentially, since dalawa lang yung carbon niya, nandun yung carbon-carbon double bond. It reacts with hydrobromic acid, and in the process, it actually forms bromoethane. So, okay, hindi ko muna i-discuss paano ba yung pagdraw ng mechanisms. But this is typically how a trained chemist will talk about this reaction, this organic transformation in the language of reaction mechanism. So ako po, I will talk in my language. So for example, okay, so in this particular reaction, this is how it starts. The pi bond of your ethylene will nucleophilically attack the proton or the hydrogen in hydrobromic acid. And in the process, the bond between hydrogen and bromine will actually break. So mapuputol yan. And then what happens after that is, once the hydrobromic acid bond is actually broken, you will actually end up having that hydrogen forming a bond with carbon. And then, yung isa naman pong carbon, doon sa ating carbon-carbon double bond sa reactant, it forms a carbocation. And that carbocation is actually electron deficient. So it will find a way to complete its octet. And so what happens is, since the first step liberates a free bromide ion, that bromide ion will actually attack that electrophilic center, and then ultimately forming your product, which is bromoethane. So ganun po ang lengguwahe doon, no? Ang dami yung narinig na mga technical terms. O baka po ba naguluhan na kayo, ano ba yung mga pinagsasasabi ni Sir Jeff? So yan po yung gusto kong ituro sa inyo. So kapag po kasi nagbasa kayo ng libro, lalo pa naman ng mga textbooks na that's written in a different language, medyo ang hirap po kasi talaga nitong i-digest kasi there's a lot of technicalities around this topic. So when you talk about organic reaction mechanisms, kailangan nyo gamitin essentially yung vernacular na kaparehas ng ginamit ko. Paano po kung nagsisimula pa lang kayo? Paano nyo ba talaga ito i-approach? So, dito na po papasok yung mga prerequisites na binabanggit ko sa inyo. So, gaya na pinakita kanina ni Professor Dindy, there's a number of things that you actually need to learn or to at least have some fairly decent understanding of, for you to understand, like the topics that she mentioned earlier. But then this time around, like when it comes to organic reaction mechanisms, dalawa po yung most essential. The first of which is an appreciation of organic structures or chemical structures in general. So when we say structures, we're talking about Lewis structures and Lewis symbols. So dapat po, marunong kayo magsulat ng tamang Lewis structures and Lewis symbols, kasi pag mali po ang inyong isinusulat or dinadraw na Lewis structure representation ng inyong compound, and then automatically po mali na ang inyong reaction mechanism. Secondly is a very strong grasp of octet rule. So since we're dealing with organic chemistry and we're actually dealing with atoms or elements that typically require an octet, so you have carbon, nitrogen, oxygen, and then your halogens. So typically, okay lang na ba sa malakas or malalim yung pagkakaintindi nyo ng octet rule, that is very important. Kasi sabi nga kanina sa definition, kailangan ang ating understanding ng movement ng electrons, as they are used to form or break bonds, dapat yun po ay solid. Ang pangalawa is bond polarity. So again, yung polarity naman, doon nyo rin siya kukunin sa appreciation of Lewis structures, but then you're just combining it with the concept of electronegativity. So when is a compound polar or not? Kasi yung polarity po na yan, that will actually dictate the types of reactions or the reaction mechanism that those chemical species will undergo during a reaction. So, yan po. So, ito po, I would like to highlight at the high school level ang ating pong mga guro. Kapag po naturuan nyo ng maayos sa Lewis structures, octet rules, bond polarity, dipole moments, electronegativity ang ating mga estudyante, you're actually preparing them well for a college level learning of organic chemistry, more particularly reaction mechanism. So yun po. So ito po, gusto ko lang din pong banggitin sa inyo that we actually have, I think this is a 2.5 hour lecture on how, or web tutorial on how to actually draw Lewis structure. So like in this particular lecture, we talked about Lewis symbols for organic and inorganic compounds. We talked about covalent bonding, polarity, formal charges, and even exceptions to the octet rule. So kung ang mga estudyante po natin at ating mga guro ay kailangan ng refresher, or kung gusto po ninyo ng Tagalog-English discussion of that na in a way that's simplified, ito po, we recommend that you watch this. This is actually uploaded on our YouTube channel. So, okay. So, before natin i-discuss, before natin himay-himayin yung unang example na pinakita ko sa inyo, so the reaction between ethylene or ethene and hydrobromic acid, before ko yun i-demonstrate sa inyo later, gusto ko munang i-introduce kayo to the concept of bond formation and bond cleavage or breaking. So cleavage means binibreak ninyo, pinaghihiwalay ninyo, or hinahati ninyo yung bond, because these are the elementary steps involved in chemical transformation. So kailangan naiintindihan po natin kailan ba nagpo-form ng bond ang dalawang atom, kailan ba nagbe-break yung bond sa dalawang atom. And ito, gagawin ko, i-present ko po sa inyo ito sa pinaka-relatable na lengguwahe. We'll actually come up with a lot of real-life analogies for this. Okay. But before we actually deal with bond breaking and bond formation, kailangan naiintindihan muna natin what is a bond. So in organic chemistry po, more particularly, the focus is a covalent bond. So a covalent bond is a bond that forms between two atoms that are sharing a pair of electrons. So dito po sa ating drawing dito, there's a covalent bond between fragments or atoms A and B. And so this is what we call, or this is what Professor Dindy Voiles alluded to earlier as your sigma bond. So yung single bond na yan, we call that a sigma bond. And that sigma bond is also a covalent bond, and that is comprised of a pair of electrons. So one pair of electrons being shared by elements or by atoms A and B. So again, kailangan po basics of ano ba yung definition ng bond, dapat naiintindihan ng ating mga estudyante yan. And then Professor Dindy earlier as well mentioned about pi bonding. So this can become a double bond. So when we say double bond, the first bond is a sigma bond, the second bond is a pi bond. So pinakita po niya yung kanina. And then I'll talk about that again like later on, like in the example. Okay, so ang sabi natin kanina, we'll talk about the fundamentals of bond formation and bond breaking or cleavage. So ang una muna po natin i-cover is bond formation. So paano ba nagpo-form ang bond between two atoms? So there are two different ways by which a covalent bond can form. So the first of which is what we call a homogenic mechanism. So in the homogenic mechanism of covalent bond formation, what happens is that each of the atoms participating in the covalent bond will actually contribute one electron. So ito po yun. So atom A has an unpaired electron, and then atom B has an unpaired electron. So kumbaga po sa group project, kung ang binigay na assignment ng teacher ay, okay, student 1 and student 2, mag-form kayo ng bond. Gumawa kayo ng project together, ang expectation ng guru dyan ay equal participation. So ito pong homogenic, ganun po yun. So yung ambag ni B ay equal sa ambag ni A. Pag nag-form sila ng bond or kapag gumawa sila ng project, di ano yun, patas yung group work ano po kasi parehas silang nag-contribute. So that is what we call a homogenic mechanism for the formation of a covalent bond. Okay, and typically, when it comes to organic reaction mechanism, so nakita niyo siguro sa example si Professor Dindi kanina, she was using arrows to demonstrate, the formation of bonds or the breaking of bonds. So when it comes to homogenic bond formation, i-represent natin yung flow, your movement ng electrons using a fishhook arrow. So isa lang, kung makikita nyo, yung hook niya is isa lang. So kapag nakita nyo po yan sa organic reaction mechanisms na nakadraw sa textbook, ibig sabihin yan, you're actually moving one electron or an unpaired electron. So in this case, there's a fishhook originating from B going into this region where A and B will form a bond. Ganon din po yun. Yung A, it has an unpaired electron. So therefore, yung fishhook rin will represent the movement of its electrons. So when those electrons, or essentially the orbitals where those electrons are present when they overlap, that results in the formation of a covalent bond. So again, tandaan nyo po yan, fishhook. That's how you represent single electrons moving during an organic reaction mechanism. So yan po yung papakatandaan po natin. And we call each of these species which has an unpaired electron, it's called a radical. So this is like a radical type mechanism for covalent bond formation. Okay. Next naman po. So kung kanina, homogenic mechanism, this time naman, we have this mechanism called heterogenic bond formation. So this time around naman, ito yung mas madalas siguro na-experience ng mga estudyante at mga guro sa klase. No? Kapag nag-assign ng project ang teacher, okay, go group into partners, student A and B, magagawa kayo ng project. Minsan, natsitsempohan, ang isang estudyante ay tamad, walang ambag. Yung isa naman, sobrang bibo or maraming resource, additional lang yung gagawa. But then at the same time, minsan yung mga estudyante naman na mga bibo, wala naman din po masyadong pakialam. So they're willing to share their electrons. So in a heterogenic mechanism for bond formation, the electron pair will only come from one source or from one atom or from one fragment. So this time around, B yung atin pong source ng electron pair. Tumatanggap lang si atom A, and that's how they form a bond. And whenever we and then this time around, since hindi po equal yung kanilang yung kanilang pag-share ng electron, kasi yun ang gagaling lang kay bilat ng electrons, si A tumatanggap lang siya. So we actually have terms for these species. So nabanggit rin ng Professor Dinti kanina, yung ating mga chemical species, whether it be an atom or a fragment, that is electron rich and that is acting as the donor of electron, we actually call that a nucleophile. So when we say nucleophile, it is looking for a nucleus with which it will share its electrons. Pag ito naman po dun sa element A, it is electron poor. So it prefers to accept electrons. And so since it's an electron acceptor, we call it an electrophile. So kapag po meron kayong ganong estudyante sa klase, yung isa hindi gumagawa ng kanyang ambag at yung isa naman po ay overperforming, at yun po, pwede nyo tawagin nucleophile yung isa po electrophile. So ganyan niyo po i-brand ng inyong mga estudyante. No? So, and then we typically represent the movement of electrons during the heterogenic mechanism for bond formation in this manner. So yung pong ating regular arrow, yung double hooked arrow, so since dalawa na yung hook niya, that represents a pair of electron moving. So this time around, yung pong ating electrons is a pair of electrons is originating from B and is being shared with atom or fragment A. So yan po yung heterogenic mechanism for bond formation. So kung mapapansin niyo, yung end result is just the same. So pero nagkaiba po yung mechanism by which electrons are actually shared to form a bond. Okay po ba? All right. So, kung meron po tayong bond formation, sabi ko kanina, meron rin naman tayong bond breaking or bond cleavage. So, again, babalik tayo dun sa fundamental understanding natin that, you know, a single bond between atoms A and B that is comprised of a pair of electrons. So lagi pag automatic, pag nakita kayo ng isang guhit between two elements, that is actually corresponding to a pair of electrons or two electrons. So kaparehas ng mechanism kanina, kung merong homogenic, meron namang homolytic. So this time around, what happens is that when you break the bond between atoms A and B, equal yung pag-split ng electron pair. So isang electron ends up with A, isang electron ends up with B. So kung ang analogy po dito, kung dalawa yung anak, kung kayo po ay magulang at meron kayong dalawang anak at nag-uwi kayo ng pagkain, dito na po papasok yung term na hating kapatid. So equal po yung pag-split ng electron pair between the two atoms or the two elements. So ganun po siya. But then ang result po niyan, gaya ng pagkakahat ng sinabi namin kanina, ay dalawang radicals. Kasi if you're gonna represent the splitting of the electron pair, in this particular example is such that, you know, you're gonna use two fish hooks originating from the bond, and then yung tip po nun, or yung hook, is actually pointing to the receiving atom. So atom A and atom B. So forming two radicals. So yan po ang homolytic bond cleavage. Okay, ito naman po heterolytic cleavage. So starting from a single bond between atoms A and B, what happens is that yun pong buong electron pair ay napupunta lang sa isang to only one of the two atoms participating in the covalent bonding. So dito na po papasok kung kumbaga kung may dalawa kayong anak, binigyan nyo ng pagkain, dito na po yung medyo may pagkaswapang yung isa, yung pagka-selfish, yung isa po naaagawan. So yun po yung mechanism of heterolytic bond breaking. So dito naman po, I would just like to point out a couple of things as well. So B gets the entire electron pair. And if you're going to represent the movement of electrons during the breaking of the bond between A and B, this is how you are actually writing this. So originating from the single bond, you're actually going to direct the arrowhead to B. So ang result po nito is yung A, wala siyang nakuhang electron from that bond, and then it entirely ended up doon sa B. So hindi ko po to nilagyan ng ng charges, no, kasi these are just like, you know, more generic representations. But then later on makikita na ninyo na since hindi po balanse yung pagka-split ng electrons between the two atoms, heterolytic bond cleavage usually results in the formation of it results in a formal charge, or in the changes in the overall charge of these atoms. So as early as like in those demonstrations po, I have actually shown that arrows can be used to indicate or to demonstrate the movement of electrons during a chemical transformation. So yung sinabi ko nga po kanina, if the splitting of a bond, or if the formation of a bond involves one electron, like from each participating atom, then we call that a radical process. So either you're starting with radicals to form the bond, or you break the bond to form radicals. Yun po ang radical processes that we are actually talking about. So again, homolytic and homogenic bond formation and breaking are actually what we use as descriptors for those steps. And then when it comes to kapag nakakita po kayo ng reaction mechanisms with the typical double hooked arrow, dun nyo po matatawag that these are actually polar processes where the electrons actually move in pairs. So dalawang electrons po lagi yun nire-represent ng traditional arrows. So again, heterolytic bond breaking, and then heterogenic bond formation. So yun po, keep that in mind, students and teachers. Malaki po ang pinagkaiba niyan kapag wag niyo po yung i-interchange, kasi pag ipinakita niyo po yung reaction mechanism niyo sa mga chemist, iba po yung interpretation nila, kasi these are conventions, these are actually standard ways by which we represent the movement of electrons during to represent a reaction mechanism. And then meron pa rin po yung mga certain intricacies that you have to watch out for. So the tail of each arrow should be pointed at the source of the electron. Ganun po yun. Kung saan po nanggagaling yung electron, dun po dapat nakapoint yung buntot ng inyong arrowhead. And then, the arrowhead, yun po mga hooks ninyo, these should actually point to the receiver or to the acceptor of the electron. So yung arrowhead, lagi yung nakapoint or nakaturo sa electrophile. Yung buntot po, laging nakaturo sa nucleophile. So, hindi po yan interchangeable. So, ito po yung mga usual rin na mga causes for mistakes po ng students whenever they write a reaction mechanism. So, minsan po, yung electron acceptor, parang sa kanya nanggagaling yung arrow. So, again, you're representing the movement of electron. So, kung saan nanggaling yung electron, nandun po dapat yung buntot. Kung sino yung tatanggap, dapat nandun yung arrowhead. Okay, so simple lang naman po yung mga yan. But then again, like all of these basic ways by which we represent structures during reaction mechanisms and arrows and movements of electrons, kapag pinagsama-sama yan na po yan, baka malito po kayo. Kaya it's very important that you keep all these foundation knowledge with you whenever you are writing up an organic reaction mechanism. Okay, so mabalik tayo dun sa example. So, kanina pinakitaan ko kayo nitong given. So you have ethene plus hydrobromic acid, and then it reacted to form bromomethane. But then how can you actually come up, or how if we were to ask you to draw a probable and a reasonable reaction mechanism for this, how do you start? Paano niyo po ba yan naalamin? So dito, actually po, if yung prerequisites na binanggit ko sa inyo kanina, if you have an appreciation of the structure, of the right structures, of the octet rule, of bond polarity, of dipole moments, kahit po hindi nyo masyadong alam, or hindi nyo nabasa sa libro ano bang type na reaction yun, you'll be able to figure out a way by which you can draw a reasonable reaction mechanism. And yung first step po typically dyan is you have to analyze the structures of your reactant. So dito po, we have to analyze the structure of ethene, and then we also have to analyze the structure of hydrobromic acid. And this is how we are going to do this. So this is the structure of ethene. So sinabi nga po kanina na Professor Dindy, there's a carbon-carbon double bond present in there. And ito po, ide-demo ko sa inyo. I need to be able to see myself as I do this. I'm just gonna move. Okay, my camera somewhere there. So ito po yung three-dimensional, it's a ball and stick representation of ethylene. So ito po, it's actually a planar molecule po where this is your carbon centers forming a carbon-carbon double bond. So yung una po ditong bond is the sigma bond, and then the other one is the pi bond. And then planar po, coplanar po with this bond are all the carbon-hydrogen bonds. And typically po, for most of the hydrocarbon transformations na tinuturo sa high school, no, these carbon-hydrogen bonds, unless in the presence of radicals, they don't usually react. Lalo-lalo na po sa alkenes. All of these vinylic carbon-hydrogen bonds are very strong bonds, so hindi po sila masyadong reactive. But then ang focus po natin ngayon is actually in this region. So this particular region has two bonds. So it has two pairs of electrons. So ilang electrons yun in total? It has 4 electrons around this region. So if you could imagine this po, itong gitna ng part na to, this is electron-rich. Marami siyang electrons. And then one very important thing is that the pi bond is actually is relatively more reactive than your typical sigma bond. So it's the presence of the pi bond that's making this fairly reactive. So gaya nga na po na sinabi ko dito kanina, in-indicate ko na ito, this is a region that is fairly rich when it comes to electron density. So dito po, since this region is electron rich, you can actually call this region or the pi bond a nucleophilic area. Okay, so it's a nucleophilic part of your ethylene or your ethene molecule. Okay, now, mapunta naman tayo dun sa hydrobromic acid. So sabi ko nga sa inyo kanina, if you have a very good understanding of Lewis structures and bond polarity, malalaman nyo, how would these behave during a reaction? So hydrobromic acid here, as I was telling you, is a polar, as I mentioned before, is a polar compound. So why is it polar? Because bromine is more electronegative than hydrogen. So when they form a bond, what happens is that an electronegative atom tends to withdraw or tends to attract more of the electron towards it. So kahit po itong hydrogen bromine bond dito ay single bond, majority po ng electron cloud dito ay napupunta or lumalapit sa bromine. And that results in a net dipole moment, making it a polar compound. So sabi natin, more of the electrons are attracted towards, or actually, attracted towards bromine. So therefore, yung bromine dito is partially negative. Pag sinabing partially negative, mas mataas yung electron density around it. Pagdating naman po sa hydrogen or the proton in this structure, partially positive siya. So kasi naaagawan siya ng electron eh. Medyo may pagkaswapang po itong bromine. So in this case, partially positive yung hydrogen. And 'di ba sinabi kanina na Professor Dindy that, regions in a molecule that is partially positive, that is electron poor, and therefore you can call it an electrophilic center, an electrophile. Yung region naman that is electron rich, which is bromine in this case, is nucleophilic. So, and then yun naman pong pi band or yung region dito that is very rich in electrons is also what we call a nucleophile. So kapag ganito na po yung inyong dissection ng structures of your reactant, malalaman nyo na alin ba dito yung posibleng mag-react. So therefore, dito kung iisipin nyo po, bromine, you can call it nucleophilic. Pero ang tanong po, between these two species, meron bang region dito sa ethylene na pwede siyang i-attack? Parang wala naman. Kasi diba sabi ko sa inyo, these carbon-hydrogen bonds are unreactive. So therefore, walang region na pwedeng i-attack itong bromine dito sa inyong ethene. But then the other way around, your electron-rich area here in ethylene can attack the electrophilic center of hydrogen in hydrobromic acid. And that is actually how you map out the first step in a reaction mechanism. Ano ba yung mga parts? Ano ba yung moieties in your molecules na yung charges are yung nucleophilicity and electrophilicity are actually matching. So essentially po dito, yung konsepto lang ng opposite attracts. So dito, ang first step is that your pi bond or your electron-rich center between those two carbons in ethene will actually attack your electrophilic center. And why is that? It's because this is electron-rich, this is electron-poor, so partially positive, partially negative, opposites attract. So yan na nga po yung sinasabi natin, diba? Sa love life, yung good girls laging gusto ang bad boys. Parang ganon yung gagawin yung analogy dyan. So what happens here is that, ito po, I'm gonna be using a model here. If this is the pi bond, what happens is that your ethene molecule will actually use it to abstract or to attack your, to abstract your electrophilic center here, which is your hydrogen. So parang yung pong first step po sa chemical reaction is such that your molecules should actually orient themselves in a way that's making that will make it possible for them to bond. So dapat po meron rin silang specific distance in space and orientation for the reaction to happen. So dapat po nagdidikit po yung mga yan. So kumbaga po sa bonding ng mga pagkakabarkada, mahirap po makipag-bonding kapag ang inyo pong kabarkada ay nasa malayo. So kailangan po didikit yan. So what happens is that yung initial orientations in space po niyan is that your proton should be close enough to your pi bond. And so what happens is ito po yung transition state na tinatawag natin. So dumidikit yung hydrobromic acid dun sa inyong ethylene molecule, and in the process, your ethylene molecule is actually using its pi bond to attract or to abstract your hydrogen here. And then so what happens afterwards is that yung electron pair dito sa carbon-carbon double bond is being used to form a bond with hydrogen here. And in the process, kung mapapansin niyo po, nagfo-form ng bond between your alkene and your hydrogen with hydrobromic acid. And so ito po yung tinatawag natin na hypervalent proton or hydrogen. Sinabi natin hypervalent kasi it is actually getting surrounded, at least at this point, by number of electrons that's beyond what it can accommodate. Kasi ano nga po ang ating rule when it comes to yung bonding with hydrogen, a hydrogen atom can only has a 1s orbital, and that 1s orbital can only accommodate 2 electrons. So kapag po dinonate or kapag inattack ng inyong ethylene molecule yung inyong proton dito, therefore nagdo-donate pa siya ng electron pair. Eh meron na siyang electron pair dito, so magiging 4 na yung electrons around it. So that's what you call a hypervalent atom. And since lumalagpas na siya dun sa kanyang maximum number of electrons that it can accommodate, what happens is that kapag nag-form na siya ng bond with, kapag nag-form na siya ng, saan nakikisama yung model ko, kapag nag-form na siya ng bond with your ethylene, like this, what happens is that it also breaks, the hydrogen breaks its bond with bromine. So ito na po yung mangyayari dyan. Yung next step dyan is that bond between hydrogen and bromine will actually break. So in the process, the electron pair that was initially used to form a covalent bond with hydrogen ends up being taken away by bromine. So ganyan po yung nangyayari dyan. So ito na yung resulting species nyo dyan. So yung hindi po stable ang hypervalent hydrogen, therefore it has to break a bond. It has to let go of something. So yun po. And so what you end up with is this structure. So you have your hydrogen atom from bromine attaching to one of the carbon atoms. And in the process, medyo nakakalungkot po para dun sa pangalawang carbon, kulang siya. So it only has 3 groups around it. So 3 bonds around it. So therefore, it only has 6 electrons around it. Eh, ilan po ba ang kailangang electrons ng isang carbon atom for it to be stable? It has to have it has to have a total of 8 electrons. Kaya nga po, octet rule. And this particular electron deficient carbon species is what we call a carbocation. So it is a positively charged carbon center. So yun po, papakatandaan niyo po yan. Yun yung sinasabi ko kanina na when it comes to polar additions or when it comes to heterolytic bond cleavages, usually it results in the formation of species that are actually charged species. So positively charged carbon atom or carbon center and then a negatively charged bromine center. Okay, so ano po ba nangyayari dyan? So one very important thing that you have to keep in mind is that again, since the carbon, and I cannot emphasize this enough, since this carbon only has 6 electrons around it, it's unstable. So, kumbaga sa love life, ito po siya yung naiwan. Siya yung naiwan sa relationship. So, siya yung nakulangan sa sarili. So, and then ito naman pong si bromine, tinangay niya lahat. So, siya yung medyo may mga sobra naman siyang daladala. Okay. And so, as I've mentioned, carbocation, positively charged carbon, electron deficient, it is unstable. So, therefore, sabi nga natin, unstable siya. Therefore, it's very active. Hindi siya kalmado. So paano ba siya makakalma? So it can only be stabilized if it will get what? An extra pair of electrons to complete its octet. So what happens during this reaction is that since the bromide ion is just lingering around, what it's gonna do is that it's gonna use one of its electron pairs to attack this electrophilic carbon center. So in the process po, kumbaga sa nag-break, nagbalikan din naman po yan. So ang nangyari po, hindi pa rin nakipagbalikan, nag-form siya ng bond dun sa carbon atom. So iba na yung kapartner niya. Nakahanap na siya ng kapalit. So yun po, that's the process by which you actually stabilize that carbocation. You need a nucleophile to donate an extra pair of electrons to form your ultimate product, which is bromoethane. So yan po yung tinatawag natin na organic reaction mechanisms and then if you're actually gonna examine the net reaction po you started with ethene and hydrobromic acid. So what happens here for ethene during this reaction is that the pi bond was broken. The pi bond was broken because the electron pair and that pi bond was used to form a bond with your proton, and in the process your HBr bond is broken, and then ultimately the net effect is that you formed a carbon hydrogen bond and you also formed a carbon bromine bond. So that is what we call a polar addition across an alkene or a carbon-carbon double bond. Okay, so medyo madali lang po siya, hindi niyo siya talaga kailangang memoryahan step by step ba niyan. Ganyan. Kailangan niyo lang na-appreciate, okay, octet rule, right structures, polarity, charges, yun po yung mga bagay na basic knowledge that you will learn from high school. So ito po yung sinasabi ko na kapag medyo hindi solid yung appreciation ng mga bata sa basic concepts na yun, pagdating nila ng college, hindi nila masyado itong ma-appreciate kasi hindi nila masyado nare-retain po yung foundation knowledge. So ganito ko po ito in-approach nung ako po yung nasa undergrad pa sa UP, and it actually worked. You'll be able to ace all of your exams when it comes to organic reaction mechanisms kung solid ang grasp of Lewis structures, polarity, and electronegativity. So mahalaga po 'yun. And ang maganda po kasi dito is that kahit po palakihin nyo yung alkyl chain, pag alam nyo po na yung polar groups lang yung magre-react, hindi kayo malilito kasi alam nyo ito lang yung reactive na part kasi yung iba naman hindi naman sila nagpa-participate. Yun po yung importance of actually making sure that you have a very great understanding of all of these steps. Okay, and then yung i-introduce lang po namin sa inyo kanina is the concept of transition state, yung orientation in space ng ating mga chemical species for them to react. Kasi kailangan niya po yan, kailangan nagdidikit for your chemical bonds to form or to break. And then yung concept of an intermediate. So yung concept of an intermediate is actually when I showed you yung carbocation formation. And typically, these types of intermediates form whenever a particular reaction requires more than one step. So kung multiple steps po involved for you to get to the right structure or to the structure of your product, usually there is a chemical or a reactive intermediate involved. Okay. So ito po, mas sabi nga kanina doon sa outline ko, practice makes perfect. So this time around naman, let's deal with or let's try to tackle these two examples. So you have propylene reacting with hydrobromic acid to form 2-bromopropane. So ito po yung top example. And then yung pangalawa namang example po is that you actually have 3-methyl butene reacting with hydrobromic acid to form this species. So sige nga po, paano ba natin i-name to? So when we are naming alkyl halides, we actually we identify the longest chain, which is actually 1, 2, 3, 4. So this is actually gonna be 2-bromo, 2-methyl butane. So yun po. So yun yung product natin. So ang challenge sa inyo, kung meron po kayong pen and paper dyan, try to come up or to propose a reasonable and probable reaction mechanism for this. So I'll actually give you siguro a couple of minutes to copy these examples, and then after that po I will be showing you the answer kung paano ba natin nakuha tong reactions na to. So Marty, pwedeng orasan mo ng 2 minutes, and then after that siguro let's give them some time to answer to come up with an answer, and during that period baka JP, do we have some announcements that we can actually share in the meantime? Yun. So yun po, kopyahin niyo muna yung example na yan, and siguro we're gonna give you siguro 5 minutes to try to answer to try to come up with a probable and a reasonable reaction mechanism for this. And then after that, ipapakita ko po sa inyo through slides and also using organic models. All right.
Should we make some announcement now, or?
Siguro JP, 1 minute for them to copy the structures, and then after that do the screen sharing.
Okay.
All right. Thank you. Okay, JP, siguro they can let's just do the announcements habang nagsasagot sila.
All right.
Thank you.
Mm-hmm. A sec. All right. So, can you hear me?
Yes, Kuya.
Yeah. So, as mentioned earlier po, we have the training course number 7 of the Phil-Sci Research University next week. This is going to be about um, the best practices on writing a thesis or the thesis writing process. And this will be delivered by Professor May Joan Aguila of the Institute of Chemistry, University of the Philippines, Los Baños, next week at 10 a.m. So yung registration po is on our Facebook page and also on our website. So kindly check that out. So next week, we're gonna start at 10 a.m. And ayun po, this is also gonna be Zoom and YouTube live event. So that's training course number 7 for the Phil-Sci Research University. And malapit na po tayong matapos. So if you wanna catch up on the courses, kindly check it out on our website. And for every course po, we are issuing a participation certificate. So even for the recorded lectures or the webinars, we issue a certificate of participation, and we're just counting on your honesty to really absorb and capture all of the lessons that we share there dun sa buong program na ito po. Okay? So that's gonna be next week again, June 12, Independence Day in the Philippines at 10 a.m. Okay? And after that, we have a special topic also under the Phil-Sci Research University program. We have Green Chemistry, Principles and Initiatives. And this will be delivered by Professor Maria Catrina Vasquez de Paz of Adamson University. And that's going to be June 19, I think Dr. Ceresal's birthday, June 19, 10 a.m. Also here on Zoom and YouTube Live. And also the registration details are on our Facebook page and website. So kindly check it out and take part of this webinar about green chemistry and its principles and initiatives. So ayan, maraming salamat po. And I think, do I have the next slide? No.
Are we done, JP?
Yep.
All right. Okay, so we're resuming our discussion. So we're actually down to our 10 slides, and these are actually mostly covering examples. So yung first example po natin kanina is involving the reaction between propylene and hydrobromic acid. So yung standard mechanism that I actually showed earlier covers this. So this reaction will start with your pi bond in propylene attacking the electrophilic center, which is this hydrogen atom in hydrobromic acid. And in the process, since it's becoming a hypervalent hydrogen atom, it has to break its bond with bromine to generate what we call a carbocation. But then this time around po, kanina kasi it's very easy. When ethylene reacted, symmetrical po kasi yung the ethylene molecule is symmetrical, so therefore whichever carbon you attach the hydrogen, wala pong diferensya, it will just give you the same carbocation. But then in the case of propylene, what happens is that there are two different positions on which you can attach your hydrogen atom or your proton. We typically call it as a proton po, and like for polar reaction. So it can either attach to the terminal carbon atom, to form a secondary carbocation like this, or then this can actually attach itself to the middle carbon, generating a primary carbocation. So bakit ba natin tinatawag yan na primary, secondary, at saka po tertiary? So when we classify carbocations based on the number of carbon atoms that are actually attached to your carbocation center. So in this case, I cannot see my camera. Okay, I guess. Okay. So in this case po, you actually are you have the carbocation center, and then we classify it as a primary, secondary, or tertiary depende sa number ng carbon atoms attached to it. So in this particular example, this is your carbocation center, and it has 1, 2, 3 carbon centers surrounding it. So therefore, we classify this as a tertiary carbocation. And then if we remove one carbon and replace it with a hydrogen atom. So in this particular case, it'll look like this. So this carbocation center only has 1, 2 carbons atoms or carbon centers around it. So therefore, since it's only 2, then it's a secondary carbocation. Okay, now if you remove another carbon and you replace it with hydrogen, so this carbocation center only has 1 carbon center attached to it. So therefore, we call it a primary carbocation. So now when it comes to carbocation classifications po, the more carbon centers surrounding your carbocation center, the more stable it is. So yun po. So what I really would want to communicate here is that the most stable amongst the different types of carbocations that can be formed is what we call a tertiary carbocation, because it has 1, 2, 3 carbon centers around it. It's followed by a secondary carbocation which has 1 and 2 carbon centers around it. Of these 3, the least stable carbocation is a primary one because it only has 1 carbon atom around it. And bakit po ba ganun? So, ang sabi po natin, a carbocation center is an electron deficient center. So, kulang siya ng electron. So, what happens po is there's this phenomenon called hyperconjugation. So, hyperconjugation po, it's a way by which carbon centers can stabilize or can partially donate electrons through its sigma bond. So it's a very technical topic, and I will discuss it in a separate session. But then for now, we'll just accept that phenomenon occurs. Like if you have a carbon center attached to a carbocation that can stabilize your electron deficient center. So kumbaga po, analogy nito in real life is that if you have a friend na nawalan or iniwanan ng kapartner, mas madali po kasing kalmahin ang tao na nawalan kapag mas marami siyang kasama, kapag napapaligiran siya ng kabarkada. So kapag tinanggal yung support group ng inyong carbon center na yan or ng kaibigan nyo na nawalan or nasaktan, sino pong kakalma dyan? So it's becoming unstable. So yun po. So when it comes to reaction mechanisms, intermediates that are more stable, sila po yung mas favored na mag-form. So therefore, if your intermediate has a way to form the more stable carbocation, it will do that. So okay, so babalik tayo dito dyan sa example na yan. So what happens here is that your hydrogen attaches itself to the terminal carbon center for you to form the secondary carbocation, again, because a secondary carbocation is more stable than a primary one. And so since it's more stable, its formation is more favored. Yan po ang ifo-form ng nature. So ang nature po talaga ay meron sariling preference. And so since you form a secondary carbocation in this process, what happens is that your bromide ion will end up what? Attacking the electrophilic center that is this secondary carbocation. And so when it does that, the resulting product is this. So what happens is your proton attaches itself to the lesser substituted carbon. Your halide attaches itself to the more substituted carbon. Ito po yung tinawag kanina ni Professor Dindina Markovnikov's rule. So when you're doing polar addition, say of hydrogen halide compounds across a carbon-carbon double bond, the bromide or the halide will attach itself to the most substituted carbon. So ito po, papakatandaan niyo po yan. Yung hydrogen, doon lagi siya pumupunta sa gilid according to Markovnikov. Doon siya sa less crowded na area. Doon yung gusto pumunta ng hydrogen. So ito po, students and teachers, don't forget about this because this is a very important rule when it comes to proposing reaction mechanisms or even predicting the products for reactions of alkenes. Okay, and so we're actually going to be making this more challenging. So this time around, we are actually using 3-methyl 1-butene reacting with hydrobromic acid. So sabi nga natin kanina, what happens here is that you start with the nucleophilic attack of your carbon-carbon pi bond at the hydrogen center in hydrobromic acid, and in the process, this hydrogen bromine bond will break to form, in this case, following the Markovnikov rule for the first step, a secondary carbocation. So yun po kasi yun. So you form a secondary carbocation. So, but the question is it happy enough? So sabi ko po kanina, if a particular intermediate or if a particular reaction or structure can form a more stable carbocation, it can rearrange. So there's this process called rearrangement that can happen. So ano po ba pag sinabi natin rearrangement, what typically happens is that, so this carbocation is surrounded by how many carbon atoms? So it's surrounded by this carbon atom and also surrounded by this carbon atom. So what happens is, if you would use this as a reference point as carbon number 1, then you have 2 different types of carbon number 2. So either this one or either the one on the left. And so what happens is that one of the groups in your C2 position can migrate to this carbon center to form the more stable carbocation. So for example, if we are to move or if we are to shift this hydrogen atom, kung ilalagay po natin siya dyan sa center, you'll be left with a primary carbocation kasi this carbon center is only attached to one carbon center. But then the other way around, if you would consider the second C2 position to the left of this carbon, say for example, if we move this hydrogen center over to the carbocation center, what actually happens is you will form a tertiary carbocation. So ito po yung process na mangyayari dyan. We call this a 1,2 hydride shift. So this carbon-hydrogen bond, so you move the hydrogen and this pair of electron with it, and you move it shifts to the carbocation center. So ano bang resulting structure dyan? Once you do the 1,2 hydride shift, what happens is that you form this tertiary carbocation. So, bakit natin siya tinawag na tertiary? How many carbon atoms are attached to it? 1, 2, and 3. So, if you're going to compare this with the original secondary carbocation, this is actually more stable. And this is actually what's happening in reality. So, once you do this reaction, makikita nyo po is that hydrogen will transfer to the middle carbon of the secondary carbocation for you to form this tertiary carbocation, and it is actually this tertiary carbocation that the bromide ion will attack. So ito na po yung mangyayari. The nucleophilic attack of bromide will happen to the most stable carbocation. So yun po yung tinatawag natin na rearrangement when it comes to reaction mechanism. So these are things that you have to also know. So sinabi niya, kaya po pinapakilala namin sa inyo yung konsepto ng stability. So most stable is a tertiary carbocation. So therefore, nature or your active species will find a way, if possible, for it to form the more stable one. Kasi meron din naman pong mga rules that will not make it possible for things to actually shift. So, gaya nga po na sinabi ko kanina, hindi pwedeng yung hydrogen dito sa gilid ang mag-move dun sa gitna kasi it's forming a less stable intermediate. So you have to be mindful of these rules po when it comes to rearrangement. So hindi lang po siya proton, even alkyl groups, kahit po methyl group that can actually move to form the more stable carbocation. So ang suggestion ko po, if this is actually something that interests you, you check out, like textbooks po for more examples para mapakita to. And then what I actually plan to do is every once in a while po, I will schedule follow-up sessions po discussing reaction mechanisms for specific types of reactions. Kasi ito, isang type pa lang to ng reaction, nakikita nyo, ang dami na ng mga possibilities. No? So, but what I promise you that we will do later on, ay hindi pa lang po ko pa lang po ma-promise kung kailan yung mga follow-ups na yan, hihimayin po natin to this level. We will actually make sure that we actually can come up with analogies that everyone can relate to. And madali nyo pong marirecall. Ano nga yung sinabi ni Sir Jeff na parang analogy when it comes to our daily experiences, around people na marirelate natin sa reaction mechanisms. Okay, so ito po siguro, ito yung homework na ibibigay ko sa inyo, no? And I highly encourage you to post your answers po dun sa ating Facebook page. Try to work on this reaction. Draw a probable or propose a probable reaction mechanism for this reaction. So this is a reaction between an alkene with hydrobromic acid forming the structure that's actually written, that's drawn below. So pakikopya na lang po, and then yung po, paki-post ng answers nyo doon sa ating Facebook page. Ipopost ko tong picture na to doon, and then baka pwede nyo sagutan sa comment section. And I would actually engage with you on that post. Ipapakita ko po sa inyo kung paano po ba ito ginagawa. And who knows, I might actually be able to shoot for a 2 to 3 minute video to actually explain how you end up with that particular structure of a product. So ito may mga alkyl shifts pa rin na nangyayari. So ito po yung challenge problem for that. Okay. All right, so I will be posting this on our Facebook page po. And then at this point, again, I would like to leave you with just these prerequisites po. So reaction mechanism, the types of reactions po that we discussed like from the first part of the discussion. Technically po, if you have again a good appreciation of chemical structures, bond polarities, octet rules for formal charges, hindi niyo po kasi kailangan talaga mag-memorize sa organic chemistry. Kailangan niyo lang pong i-leverage itong mga basic concepts na natututunan ninyo sa high school. If you take all these basic chemistry concepts to heart, kahit po anong iba tong complex structure sa inyo, alam nyo kung paano magre-react yung mga functional groups na yan. So, hindi po ito actually po, if you study organic chemistry by memorization, hindi po yan masyado magsistick sa inyo. But if you actually learn the art of drawing reaction mechanisms or imagining the transformation of those molecules in your head, yun po kasi that's what we call, like learning things by heart. So kahit po hindi nyo alam yung name ng reaction, ipakita lang sa inyo yung structure, alam niyo na kung anong gagawin dyan, alam niyo na yung first step. So that's actually how I would like to encourage you all to learn and practice writing organic reaction mechanism. So yun po, we would be happy to answer questions po, but then again at this point I would like to leave you like with these two main prerequisites for you to be able to perfect the art of reaction mechanisms and arrow pushing. Maraming salamat po.